when a nuclear disaster happens, how do we even begin to measure it? Is there something like a Richter scale but for meltdowns? Well, today we're going to find out.
It's a really important question, right? How do you actually communicate just how bad a nuclear incident is? I mean, a tiny leak is obviously not the same thing as a full-blown meltdown. To get a feel for this challenge, let's just think about a few of the big ones you've probably heard of.
You've got 3 Mile Island. That was the partial meltdown back in '79 in Pennsylvania that, wow, really put the entire world on edge. Then there's Fukushima in 2011, a terrible disaster set off by a massive earthquake and tsunami. And, of course, Chernobyl, the 1986 catastrophe that's become the poster child for nuclear disaster. So we have these 3 events in our minds, but how do they actually stack up against each other? And that's the core problem. How in the world do you create a single system that can clearly and quickly tell everyone, not just scientists, but the public, governments, everybody, what they're dealing with? Well, the official tool built for exactly this job is called the International Nuclear and Radiological Event Scale, or for short, INES. You can basically think of it as the universal language for talking about nuclear safety. It was rolled out back in 1990 by the International Atomic Energy Agency, and it had one very clear goal: standardize the conversation. The idea was to get everyone, everywhere, on the exact same page when something went wrong. Now, this is the most important part to get about INES. It is a logarithmic scale. So this isn't a simple step-by-step ladder. Just like the Richter scale for earthquakes, every single level you go up means the event is roughly 10 times more severe than the level before it. So yeah, the jump from a level 4 to a level 5, that's huge. But going from a level 4 all the way to a level 6, that's not just another step. We are talking about a massive, massive leap. It's about 100 times worse. Okay, so the scale has 7 levels in total. They go from tiny anomalies all the way up to major accidents. For now, let's just focus on the top end, the ones that actually make the headlines. So at level 5, you've got what they call an accident with wider consequences. That's where 3 Mile Island sits. Level 6 is a serious accident, like the Kishtim disaster in the Soviet Union way back in '57. And then you get to the very top. Level 7, a major accident. And there are only 2 events in history that have ever been given that rating: Chernobyl and Fukushima. But this is where things start to get a little tricky, because lumping those 2 events, Chernobyl and Fukushima, together at the very, very top of the scale, well, it starts to reveal a potential crack in the whole system.
That's right. Both Chernobyl and Fukushima are classified as level 7 events, the absolute highest rating you can get. According to the official scale, they are equally severe.
But, were they? Let's be real. Chernobyl was this massive violent explosion that literally blew a huge chunk of its reactor core straight up into the atmosphere. Fukushima was an awful, drawn-out crisis for sure, but the total amount of radioactive material it released was only about 10% of Chernobyl's. And this is where the INES scale starts to feel a little, well, incomplete. And this has led to some pretty serious criticisms. Some people argue that INES is more of a public relations tool than a purely scientific one. It has that hard ceiling at level 7. What would we even call an accident that's worse than Chernobyl? But maybe its biggest flaw, the one critics point to most, is that it kind of mushes together an event's magnitude with its intensity. It's basically mixing up the cause and the effect into one single number. So, in response to these exact problems, especially after Fukushima, some scientists proposed a totally new way of looking at this. It's called the Nuclear Accident Magnitude Scale, or ANS, and its whole approach is honestly radically simple. It says, let's ignore everything else and focus on just one thing: the total amount, the pure magnitude of radioactivity released into the atmosphere. And when you apply this new scale, wow, the whole picture changes dramatically. On NAMS, Chernobyl is all by itself at an 8.0. But look at this. 3 Mile Island, which was just an INS level 5, scores a 7.9 on this scale. That is higher than Fukushima's 7.5. So how is that possible? It's because NAMS only cares about the total radioactive release, not the immediate impact on the ground. The whole point of NAMS is to be objective and continuous, with no ceiling. It's trying to do for nuclear events what seismologists did for earthquakes: measure the raw energy of the event itself, the magnitude, separately from its impact on people and places, the intensity. It separates the cause from the effect.
So what does this all mean? What's the big takeaway from all this talk about scales and numbers?
Well, I think it shows that trying to classify these incredibly complex disasters it's really, really hard. INES isn't necessarily wrong, and NAMS isn't automatically right. They're just different tools for different jobs. One is for quick public communication, the other is for precise scientific measurement. At the end of the day, these scales are our best shot at translating mind-boggling complexity into something we can understand, compare, and hopefully act on.
And it leaves us with this final, really tricky question. How do we make these huge, complex risks simple enough for the public to understand quickly without losing the details that are absolutely crucial? That's the balancing act we're all still trying to figure out.